So I passed from the higher level view to the detailed view. For each of those components, we have in these slides added more details. For each component, there is a name that allows you to identify the component in the list of virtual machine and Dockers or Docker Compose to create it. So the main is the dashboard builder, data inspector, user statistics, external service, resource manager, My KPI management, synoptics, and all the other features you may have here. And the knowledge base, KBSSM, is the knowledge base for semantic reasoning and navigation. It's also include the Virtuoso database that can be clustered also. And the next one is the GeoServer, GIS GeoServer that can be used for the distributing heat maps and images for the background according to the WFS, WMS protocols. The Living Lab support is a Drupal-based custom and relationship management support if you need it. Because if you don't need, you can manage the user directly with the tools inside the domain. You can add the Living Lab support only if you need to have a community or a multi-tenancy to manage the web pages for local your version of the documentation, while the general documentation is accessed on the snap4city.org. We suggest. So for clusters, for process is typically based on Marathon and Mesos, and it can be also installed on the Kubernetes, if you like. In any way, is a way to manage a number of containers for different kind of application, mainly IoT application, web scraping, RStudios, Python, and others process and components to be executed in the back office. For data cluster, you may have this optional ATL management that is presently under deprecation, so is typically not pushed in the case of small installation, only pushed and promoted for very large installation. The data shadow is the support for collecting data inside the solution. So you can collect data coming from the IoT brokers, but also coming from the My KPIs and so on, just to collect the data in the back office. So this is the cluster for the data, the big data cluster, big data cluster. You can have a number of services that are optional for routing, for chat management, for RStudio or Python, for ATL development if it's still interested for you, for engaging users and some of them. Some of them, as I told you before, may have some counterpart visible on the dashboard. And so you may have your installed IoT brokers in the cloud, or they can be outside of your infrastructure. You can develop your mobile app, your even not only mobile app but also micro application, and so you can do this kind of modularization. So is each in these slides it is reported what is inside each virtual machine, but more details are reported on the web page. So all components can be updated according to what is the last version available on the on the GitHub of DataCity Lab. You can also download the Snap4City library from the official Node-RED JS Foundation library. You can update Drupal from Drupal portal, plus component and modules that we developed for customizing and integrating Drupal with all the authentication mechanism for tenancy management and for integration with the aspects of Snap4City. The maintenance would not be a problem because all the users can apply the update. You can update also the single IoT application. There are blocks that are microservices that allow you to update the IoT app automatically. If you have problem, you can ask us to update for you. You can periodically get a new update. Each virtual machine has installed inside tools for making the update. So we can provide you a service for maintaining this your version as you like, to perform corrective maintenance and evolutive maintenance. And in any case, all the solutions are 100% open source, so you can really enjoy the new features developed for others, cities and groups, because they are putting in the open source as well, and the Snap4City is in continuous development from several parties. So you are, if you take this opportunity of using Snap4City, you are going to have a large number of new tools every month. You can set up your open source version from scratch. Guidelines are reported in this web page, and we are proposing you 7 configuration models, but you can have a mix-up of configuration. They are just configuration to provide you example of what you can do. In the configuration, you can also have your IoT Edge installed or IoT device installed and configured to be connected with the rest of the infrastructure. This is an example, is a table that describes the main configuration that are listed and identified from A, B, C, D, E, F, and F+. So A means alone, B basic, C city start, D DataCity, E extensive city, F full platform. So in this table you can see how many virtual machines you need or how many Docker you need. So the Docker version is much more scalable, so you can add fine-grained new Dockers as you need, while the virtual machine is a virtual machine-based solution are more rigid and more monolithic. But in any case, you can have Dockers inside the virtual machine to have more flexibility, and you can install your virtual machine on a team provisioning approach. So you can start with a very small amount of resources exploited by the single virtual machine, and then enlarge automatically according, for instance, to your hypervisor mechanism or cloud management. So you can, according to what you need in terms of functionality, you see here the list of them. You can select the configuration alone or basic, and you can, if you need to have all features, you need at least to start from the city start version, and then add more capability and more resources and scale up your infrastructure. In most of the configuration, you can install optional tools like ATL development. if still needed on side. You can add Living Lab support, you can add RStudios, you can add several other features as listed in this case. So routing support, Engager, Chat Manager, and Datagate Seeker, and so on. All the configuration may have multiple IoT brokers, may have support for high availability DRS, fault tolerance and balancing, so you can install them on cloud and to create a very robust solution as we have. You may pass to the next configuration without reinstalling the virtual machine. You may add one or more optional services according to the list reported in the column. And from configuration extensive city, you can have a scalability aspect, so it's possible to scale up dynamically your solution, so you can really add more and more resources to follow the growth of your solution. While in a lower configuration from A to D, you don't have a scalable capability in terms of process, and so you need to scale to put the hand in your configuration. But this is not a problem typically if you have a small solution. We suggest using the Living Lab only in the full platform, but it's up to you. You can download and install even that part. So each virtual machine in this configuration is so from the point of view of scalability and computational and storage cost, the solution we propose is based on virtual machines or Docker. The virtual machine that you have seen in the table are typically based on 1624 cores at 2 GHz and 1624 gigabyte of RAM of memory, and also 500 gigabytes of hard disk of storage. But all this kind of storage is considered in team provisioning to allow you to scale up in vertical scaling of your virtual machine. So the virtual machine can be installed and deployed in a team provisioning manner. So you usually start with a footprint of 25, 40 gigabyte each, depending on which kind of virtual machine you have among those of the Snap4City appliance. In most cases, these virtual machines are Debian, and depend of the usage, the actual usage of the space, of the hard disk space, is dependent on the amount of data that you are putting inside. If you have a small footprint, you can a small application you could remain under 100 gigabytes very easily. So it's not needed to have a large amount of storage. If you adopt a Docker solution, is probably more flexible, more fine-grained, so you can identify the Docker by Docker, container by container, the space to be used. You can have Docker inside the virtual machine. So when you start, for instance, a city version, for example, the extensive city or a DataCity version, you can, based on Docker, so you can install everything in one single virtual machine with 24 cores and 16 gigabytes of RAMs and 500 gigabytes of hard disk, everything inside. And you can enlarge your storage with additional clustering storage as you need. So depending on what you have, of the application that you are going to produce, the scalability of the solution can be on the front end for providing services on the mobile app. In that case, you need to have a scalable and balancing and so on in the cluster of Smart City APIs production and service through the IoT app. In that case, you have to scale only the front end mainly for the APIs. If you have many users on the dashboard, for instance, if you are producing this dashboard for the hotels or for totems with thousands and thousands of users using those dashboard, and the same for the Smart City API. If you have many hundred thousands or 10,000s of mobile user on mobile application, you need to scale that part. Otherwise, you don't need to scale. So they can be scaled separately. So you can separately scale the front end for the Smart City API and the front end for the dashboard. You may have cases in which your Smart City solution is not focused on producing results and the services for your end user. So you don't need to have to feed mobile app, and maybe you are only supposing to produce a service for decision maker. In this case, probably you don't need to have a very powerful front end because you have only a few users in the front end. While in this case, you may need to have a very large amount of data on which you need to make a lot of data analytics and a lot of simulation, and so you need to have a powerful hardware and process to start the different simulation to produce to perform a what-if analysis and so on. In this case, you probably need to scale up the back office more than the front end, and the front end would be probably light, very light in managing the resources, also in providing a lot of services. So the Snap4City allow you to decide and to use the same solution with the different kind of scalability you need, and you can have thousands of users in the front end for the back office. If you need to scale, and from thousands of users on the APIs, and also many data stream arriving there, and also process for the data analytics. You can have also even all together a very large platform in which you have a very powerful back office with a very large storage and a very powerful front end with a lot of users. You can scale from single virtual machine with everything inside to a very large solution with many users in the front end and also in the back office for data analytics. I have here a number of configurations that are those that reported in a 471 page, in page number 471 in the portal. You can see more details in the web page, because the web page is continuously updated with the new issues, with the links, and with the configuration files, with that is needed for you to exploit the Snap4City. So the alone configuration is very simple. You just need the virtual machine with main. You can you have inside there the dashboard builder, engine, inspector, external service, menu, ownership management, so data type ownership, authentication and authorization, WebSocket, secure server, secure manager, user statistics, JavaScript, web app, micro application, synoptics management, IoT device management, IoT directory, and Snap4City microservices on one IoT hub, only one IoT hub, and the Snap4City Web WFS player, so a tool for visualizing WFS in the dashboard, and what if analysis tools, but not the router. So you can have all this. This solution is typically suggested for very small solution, data-driven solution, Industry 4.0, small business, small cases like a smart parking management or a smart light management. You can do it all in one, or an industrial plant. So this is a very, very small footprint solution with one single virtual machine. For instance, the documentation is typically includes on how to configure the solution, the possibilities to download to the virtual machine. You can go to install and see how to download, and also how to access to download the container composed to be installed. For each of those configuration, or for most of those configuration, you have this set of information. Basic configuration adds to the previous one the possibilities to add the IoT brokers. In the previous one, it's supposed that you are going to read the external data store directly with query. So you just read the database, and the database could be MySQL, Mongo, or RDF, or let's say in general ODBC, JDBC tools. So you can access to the database and just read them, and connect your dashboard builder to the database, to what we call the metrics or KPIs. So the basic configuration had to the previous configuration, that is this one, the possibilities to add the brokers. So you can add the brokers through the IoT directories. You can add internal brokers or external brokers. So you can add virtual machines with brokers. They are called IoT Orion Brokers Secure Filter Machine, IoT Ops F. Device, appliance, you can download and install on your premise in multiple instances. You can register and connect the brokers to the main, and that's it. So in that case, you can connect all this stuff that you have in the field, and you can even connect external broker as well. So this is what you can have. You can still have one IoT application here that can connect with the brokers and create some smart solution. In this case, is a solution that could be used for a small smart parking with the IoT processing, or smart light with some IoT processing as well, or it's a very, very small solutions. But it's very powerful, and you can create your synoptics, you can create your dashboard. You don't still have not map, so you still not have map. So you may have maps, not semantics attached to the maps. So the city start configuration is the next step. The next step for city starts also includes with respect to the previous configuration, the possibilities to have maps with the semantics. Maps with the semantics means that you have to have a knowledge base with respect to the previous one. We are adding two facilities. One is the knowledge base, and the other is the GeoServer. So the knowledge base add the maps and semantics. So it means that you need to upload, for instance, a semantics mini of the area of that you are addressing. For example, you can pass from the OpenStreetMap data and use our converter that could ingest the OpenStreetMap and transform the OpenStreetMap data in the knowledge base of the area of your interest. And also had the possibilities to have a Smart City API in this case. In this case, you have a Smart City APIs, and Smart City APIs can provide you the capability to access to all the data. Semantic data mainly, and data that are located in the database, the local database. This is a mixed, very small case for a city, because in this case you may have a connection with the GIS of your city, your municipality, and you may have a connection with the IoT stuff, IoT device connected to the brokers. They can be positioned into the knowledge base by means of the IoT directory. So you can create a very a small city solution with the heat maps, also with the geo shapes, maps, and other things, but with the limited capability for semantics and for storage. These are examples that you can realize with the CityStar configuration. You see there the heat maps and the menu and dashboards. You can support, in this case, a mobile app, while in the other case, a mobile app had a limited functionality because the Smart City API were not deployed. In the CityStar configuration, you have Smart City APIs, so you can have a mobile app. You can develop your own mobile app exploiting the Smart City APIs. So DataCity configuration is the next step. DataCity configuration is more powerful, with respect to the previous configuration, had the possibilities of having a cluster of IoT, or a group, or at least a group of IoT app. Typically for each virtual machine you can add 70 IoT apps. Each of them has a large number of flows. So in most cases you don't need to have a higher number of IoT apps in your Smart City application. Let's say each data transformation or data acquisition includes one flow, but you can have 10, for instance, more than 10 flows for each IoT app. This means that you have 700 processes for data ingestion and data smartening at your disposal in one virtual machine. So this is a very powerful solution in terms of IoT and data processing. You may need to have an additional RStudio or data computing if you need to have data analytics, but the data analytics itself can be run in a container, again in the same cluster, or you may need some additional virtual machine with the containers for RStudio if you have a lot of data analytics to be added. But this part is optional, so you can scale, you can add whatever you need in the platform. Another aspect added here is the possibilities to access to the possibilities to create a data shadow. In this case, the data shadow is performed by means of a stack, NIFI, Elasticsearch, and Kibana. This is the first configuration providing this data shadow. In the previous configuration, the data shadow could be located in the broker if you need to have a local data shadow, but it's not integrated, well integrated with the rest. If you need a well-defined tool for navigating in the flows and managing all the streams that are arriving in your infrastructure, you need to have the IoT DSS cluster. You can start with one single virtual machine for the IoT DSS and then scale up as soon as you need more capability in terms of data storage and the volume of throughput in flows that arrive, data flow that arrive from the brokers. So this DataCity is also provided in terms of Docker Compose, so you can create your solution, deploying the solution by means of a set of containers from the cloud. So in these slides, you see what is included in the cluster for process, what is included in the DSS for data shadow and data storage. Optionally, you may have the ATL stuff and Phoenix Big Data, but only this is supposed that you need only if you really to scale at a large scale in your city configuration. So DataCity small configuration may be, as represented here, an instance of a reduced version with respect to the previous one, without the graphics, without the GIS, and with only one virtual machine with the Node-RED, with the IoT limited capability on IoT app, and but with the same with the IoT DSS. These are just configuration that you may need to have, or you may compose using our Snap4City components. The extensive city configuration is much larger. This means that you don't have only one single VM for cluster, but you have also a large data stream. So you need to receive, in this case, if you need to receive in this case a lot of stream data, you need to have a NIFI balancer and cluster for managing the throughput of many messages that are arriving inside the big data clusters. Take into account that this stream is managing 170,000 elements per minute arriving in the cluster, so it's very powerful, and you can scale up, take into account this kind of KPIs and measures to understand when is needed to grow up, to add one more IoT DSS component and scale up the cluster. So in this case, the extensive city is for large city, for large size smart city with many smart city application, number of IoT broker, large volume of data stream entering in the cloud, and so you probably need also a data analytics with a TensorFlow. You may need to have chat manager, you need to have routing solution. You may add a number of optional stuff that are mentioned here. So at the end, we can have also the full platform in which you may need to have a full cluster for everything, cluster on the front end, cluster in the back end for the data, cluster in the back office for managing IoT app and container in general, to have a full set of services, to have a larger set of brokers. This is what we have. In addition to this, we have also the Living Lab support. In the largest platform that we have all what is depicted here, and we have also a multiple copy of that because we have a testing tool and we have a production tool, and so for us is affordable, and we manage this kind of solution in high availability DRS and the fault tolerance for some parts when it's needed. So it's feasible, it's tested, it's up and running since more than 2 years in these conditions. So we have tools for monitoring everything that is going behind. We have tools for monitoring the back office for container, for monitoring the exploitation of the cluster, to keep in track, to understand how the resources are consumed. If you have problems, the elastic scheduler, the elastic management of the container is capable to recover the situation, to start up a new virtual machine if you grow up in a moment, and so on. The full platform plus Living Lab add the Living Lab support to the rest. So the Living Lab support is not only the Porta, but is also the Drupal. And the Drupal support can be added even in a smaller configuration, but we typically support, so we typically suggest that you use in a very large case, but you can add the Living Lab also in other configurations. The Living Lab allow you to create a page, to host user, to provide multi-tenancy organization in your platform. You can manage web page with specific documentation. You can create groups for each organization. You can keep track of which pages has been observed or not, and so you can really manage a whole platform with the Living Lab integrated as well. Some views from the administrators. So the administrators obviously have interest in observing what is going on to all the back office staff, and so to see in deep what is going on bad and good in analytics, in visual analytics, in IoT application, in indexing, in the data ingestion phase, in the query, and so on. So there are tools, specific tools that allow you to monitor all these aspects in terms of resource consumption, on cloud and on different virtual machines, and also in all the other parts. There are 2 levels of administrator. One is tool admin, and the other is root admin. Root admin is the god of everything, so it has the possibilities to define and set everything. You may have more than one root admin, and you have also tool admin that is typically focused on one single area, so IoT, knowledge base, or other things. And you can tune, you can define what the different user can access, which kind of capability, and so on. So SLA, again, you can monitoring resources with the traffic flow inside the platform. You see the management, many features for management. You can monitor how many traffic, how many data are passing from your IoT app to a given database, or from the front end to the IoT app, from the IoT or Node-RED or ETL, in terms of transmission and receive from all the process that you have. So these are numbers that I mentioned before. You monitor Cluster, I already mentioned it before that you can see the consumption of the cluster for the Docker, but you can also monitor the errors and events and logs. You can monitor the status of the web interface. You can monitor the service API. This is an example of monitoring the traffic again. You can manage a periodic process in ETL dishes or IoT app. You may have a synchronous process or synchronous process. You may enforce, you may exploit horizontal and vertical scalability. In both cases, there are mechanisms for using them. The dev dash is the dashboard for monitoring the data entering in the data shadow. It is a powerful tool that is also visible. This is the tool for traffic flow monitoring that is called the AMA. AMA means analyzer for traffic flow. It is based on Elasticsearch and Kibana and allow you to identify traffic by organization, or traffic by data kind, traffic by client and servers inside, which kind of application has created too much traffic and so on. So DevDash is the data shadow monitoring. And so you can go inside to see for data type and in the storage area by area, or with a geographic view, or with the data kind. You can filter the single analysis and go in deep to see if you have problems. You can identify very easily the problems where from which kind of device or which kind of channels are produced, if they are. I have a small video here. So you can select the different kind of sensors, device name, organization. You can select IoT streams or ATL streams if you still have ATL streams, sensor ID, value type, value unit. You can filter for each kind of value name, value type. You can even click in one of those elements and go in deep to see how that kind of segment is partitioned. You can identify, see in the details in the table, or you can decide to see a part of it and make a focus on a specific aspect of what you are looking for. I think is now it has been clicked to the piece of the pie in green, and that part has been enlarged. Now the 100% of the data analyzed is focused on that part, and that part is related to the Helsinki area. And we see that the Helsinki area has a number of sensors located there, and so you can focus and see the whole activity. So what you are looking for, what you have in the screen is the whole data analyzer, DevDash for the data shadow for the whole system. So we are addressing in this moment data coming from Helsinki, Antwerp, Tuscany, and many Leonardo Garda, SmartBed, etc. So a large flow of data, multiple organization, multi-tenancy, management, and so on. Okay, so at the level of management, you can do auditing. Auditing means that you can analyze what has been done with your data. Every person can perform some auditing related to his own variable. but the administrator obviously has the possibility to see who has done that activity in all the accounts of the system. So for the administrator, it's also very important to manage the back office. Back office means to manage the cluster, to monitor the container, how they work, if they have problems, and also to make the relationship of what is going to happen in your cloud management, for example, VMware tools, that is the tools that we prefer to use and that we are using, and the container and virtual machine. There is a support for elastic scaling, vertical scaling with increasing the resources in the single virtual machine or Dockers, or horizontal scaling, adding more containers, adding more virtual machine, on-off of virtual machine, deploying new virtual machine, and so on. All the resources are monitored at a different level, so we can monitor with a virtual machine on the VMware, but we exploit the VMware APIs to exploit all the single resources that are available in the cloud and assigned to you. So it's possible to really control from the application also the exploitation of the virtual machine inside the VMware platform. For the scaling, there is a Python for scaling algorithm. You can use Kubernetes for with the capability for scaling. This is an example of the scaling capability and an example of recovering. So we have intentionally turned off a virtual machine. All the containers has been relocated in other virtual machines and recovered in few minutes the situation, the operative situation. You have a full control of the memory and the CPU, the amount of gigahertz you have, so 76 gigahertz available for you, and with a 15 virtual machine up and running, and so the situation of how healthy was the number of process, how many process healthy containers you have, how much you consume in terms of GPUs and memory in the over time. So you can drill down, see your containers, your virtual machines are listed there. You may have a lot of these views to control and see over time where the containers have been allocated, and you can even sometimes restart some testing in addition to the workload. So this means that you don't have to turn it off your service to make testing, stress testing. You can do your stress test on the same cluster. So the system is being designed to support the stress test and runtime. So monitoring on cloud, you can see the different cluster working there. And there is also an additional scheduler that is called the dishes. If you need to schedule and process, you can exploit this distributed scheduler. So thanks a lot for attending this section of the Snap4City 2020 course. We hope to see you again in the next section.